Hello everyone, I'm Mona Adlakha from the Department of Computer Science, Aryabhat College. This video is on operating system processes. We will discuss the brief definition of what an operating system is, what system processes are, and the various process states. An operating system is an interface between a computer user and the computer hardware. It controls the execution of various programs. Examples are Microsoft Windows, Linux, Ubuntu, Apple iOS, and others. The operating system is the only one program that is running at all times on the computer. It is also called the kernel. An operating system is a resource allocator and a control programmer, and the goals are basically to execute user programs and makes solving user problems easier and make the computer system convenient and more suitable to use. It uses the computer hardware resources in an efficient manner. The OS goals are defined before the design of an operating system, and they are based on the way the system is going to be used. The hardware is designed and chosen based on the operating system goals. Now, what led to the concept of processes? Processes are central to the design of an operating system. They are required for resource sharing, computation speed up, and protecting the software by maintaining modularity. Processes are central to the design of an operating system. Process can be defined as an instance of a running program, a program in execution, an entity that can be assigned to a processor and can be executed in a processor, on a processor. Processor program is a passive entity stored on the disk, whereas a process is an active entity. A program becomes a process when executable files are loaded into the memory. The process needs resources to accomplish this task, which is your CPU, memory, I/O files, initialization data. These resources are reclaimed when process terminates. And typically systems have many processes. You have user processes, operating system processes, which are running concurrently. A program can be executed or started by using a command line interface or by a click of a mouse. And one program can have several processes, various instances of those programs. So here you can see how a process in memory looks like. And a program code, it has which is a text section, your program counter, your start, data, sections, and a heap. And you have a PCB which has details about what a process contains. Attributes, it has process states, a counter, CPU registers, CPU scheduling information, memory management information, accounting information, and I/O status information. Here we can see a diagram of a PCB. Just a few things are mentioned here, but a lot of information are stored in the PCB. And a process table, the OS also maintains pointers to each process control block, and that is how it knows where is the PCB of each process. Now, what are process states? As a process executes, it changes a state a number of times. You have new, the process is being created. It is admitted to the system running that the process is executing instructions of this process, waiting that the process is waiting for I/O or some event to occur. Ready, that the process has all needed resources and it is waiting to be assigned to the processor. And terminated, that the process has finished termination and will exit the system, whether it will be a normal or an abnormal termination. So here we can see the process state diagram. You have a new process which is admitted to the system. It comes in the ready state. When the scheduler dispatches it or allocates it to the CPU, it comes in the running state, and it stays in that state until there is an interrupt, so it goes back to the ready state. There is some I/O or event, it goes to the waiting state, or it exits the system and terminates. Again, from the waiting queue, once the I/O is complete, so it will go back into the ready state. Here are a few references which I used for this video. Thank you.